Okay, as you can see, I've already done quite a bit with my spreadsheet. Nothing I've done here is stuff that you can't do. I just want to point out a couple of things that might make the work a little faster. Once you have all the data together, which I think is easier, once you have it all here, it's not very hard to get all of your R's and M's. This is sort of the point of the spreadsheet. So here's the idea. Couple tips. You notice that I've gone ahead and done years since 1990. I've inputted 0, and then I've used that trick we used in class where I increment. I take 0 plus 1, and I drag that formula down this column so everything increments by 1. We have all the years here. Well, if all the years increment by 1, then when I'm going to do my R, I have my y2 over my y1. This is my y2, my y1. I don't need to do the exponent. Think about what that would look like if I take a3 minus a2. Well, a3 minus a2 is 1. It's 1 for every one of these. And 1 divided by 1 is just 1. But if you raise something to a power 1, it's just that number. So you can save a lot of work that way. And you can also drag formulas horizontally, and you can drag them down as well. So if you do this one formula here, you can drag it over and then all the way down and get all of the R's for all the country in seconds. Same thing goes for slope. So I have my y2 and my y1 dividing by x2 minus x1. In this case is a little silly because x2 minus x1 is just going to be 1. And dividing by 1 doesn't do anything. So I can just look at the difference. It's the difference per year because we're incrementing by years. And again, I can just take that and just copy horizontally, and then I can just copy down. And I'm getting all of those values. Now there's a problem of using all of these values that you should have seen in your graph by now, is that if we're going back all the way to 1990, quite a few of these countries have increasing rates of HIV as a percentage of population. You can see these R's greater than 1, and you can see these slopes that are positive. So in the homework, I'm going to ask you that we only go back about 10 years, or rather to go from to 2000. So if we started at 2000, right about here, which is 10 years after 1990, so I can make an easy reference mark there by just color coding that. And then I don't use any of the data above that. Right, I just X that out. And that's going to be important for my average. Let me show you why. Suppose I keep all that stuff in there. Oh, and a couple other things. Notice how I color coded here. With so much data, it's easy to get confused. So all of this green is the data. All of this orange are the R's. And then over here, the white are just the M's. At the bottom of the spreadsheet, I've done all of my min-max stuff. So, and I recopied the country names so I could see what columns I was under. So this is the minimum. This is the maximum. This is the average. Now the problem, of course, is that I'm using all of the years. And so look, this average indicates an increasing rate, 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 an increasing rate. Using all the data, we would have increasing rates in every country but the US. But your graphs would show differently. It would show that a number of these countries have decreasing rates as a percentage. Same over here with the average slopes. These all involve positive numbers, which isn't the case for recent times. So this is an example. If we use too much data, then we're skewing the results. We can't adequately predict or project what's going to happen because we're hampered by what used to be the problem. It used to be climbing, now it's decreasing. All right. So, yeah, so also, I didn't have to type all these by hand. I typed my min, I typed my max, I typed my average, I did my span. And then you can just take that column and you can just copy the whole thing right over. So if you're careful, there's only 1, 2, 3, 4, 5, 6 formulas to put in here, and then you copy the rest. Now, again, let's keep an eye on what happens to these averages after we select a slightly different bit of data. We'll highlight those. Remember, they're all indicating increasing situations. So I'm going to go up here and say, well, you know, the past is the past. Things are changing. I want to project based on what's changing. Let's get rid of that stuff. Go back down to that yellow line. Now we have, well, this one's still increasing, which should make sense from your graph. But these feature R's, some of these R's are less than 1. Right? So that's, and we have some negative slopes here. This is going to be a little different scenario. And that's going to be important in adequately or accurately trying to project future outcomes. Now, another bit here, you don't have to find B's here. I ask you for some projections, and you don't actually need to use B's to find B's here, and I'll show you how. So let's get some years here, and I'm going to just get some years, and then we have like this one, 35. This is 35 years since 1990, so it's 2025. What if I wanted to know the outcome? What's going to happen if I choose an exponential model, say? What's going to happen in these various countries? Well, first of all, let's just, and actually what I'm going to do is put 26 here. And then I'm just going to copy this data down. Because if we make a formula and then copy it, it won't like these words. So I've just copied a row here. Now what I can do is say I can take this amount, last year's, so to speak, and multiply by the appropriate R. So you can do $, I, $, what is this, 32? Right? I, 32, yep. And if I hit enter, I'm multiplying 18.9 by 1.02. This would be 2% more than previous. And I can copy this down. Right? Now the problem with that is I get South Africa, but it's not going to update if I bring it over. So there's a couple ways you can do this. But basically, this is going to allow us to not find B. So if I take 9.2 and I multiply by, this value, so it's J32, I'll put the dollar signs in there, and it's going to give me projections. Right, so I could say, well, Malawi in 2016 has 9.2%, and by 2025 it's projected to have 7%. So you can do these for all these categories. You can make projections as to what's going to happen. And the neat thing about that is you can project into the future without having to solve any equations using our models. So we could, obviously the South Africa case is increasing, but we could ask a question under the data we're using and the models we're making, when does Malawi have less than 1% of their population with HIV? Now this is it's a projection. Things could change obviously much faster with more aid or money or government policies or education. But this is one way we could use a spreadsheet to solve an equation numerically. So when does it happen? Happens 101, so that's 101 years after 1990. So that would be 2091. So that would be based on our predictions. Now, again, this is highly dependent on what data we're using. If you look at these R's under Malawi, right, 0.99, 0.98, 0.96, so things are fluctuating here a little better. Just to give you a sense for how sensitive this is, what if we get rid of a couple of these, hypothetically? What does it do to that final projection? Well, it moves it moves it up, like 7 years. So little things like that. What if we only used, data since 2010. What does that do to it? Well, that was worse. No, surprising. So maybe they've gone backwards a little bit. Anyway, we're not going to do those things. We're just going to start from 2000. But hopefully this gives you an idea of, well, it's involved. How to use the data to make projections so that you can have adequate resources to continue funding or increase funding or what have you. Yeah, so I hope that's helpful. Again, a lot of this can be done really quite easily with some spreadsheet know-how.